Assalamu alaikum. Did you know there's a building in London that's been known to reflect the sun's rays to such a degree that they've burnt doormats, they've cracked tiles, and they've even melted parts of cars? So, what is this reflection anyways? You see, when light hits a surface, it gets an option. Light can either reflect off the surface, pass through the surface, or get absorbed in between. So in this video we're going to be discussing how light can bounce off different surfaces. So reflection is simply the bouncing of light from different surfaces. Now, not all sorts of reflection is destructive. In fact, a lot of the reflection around us is useful to us because it allows us to see the world around us. So what happens is basically rays of light, they come from a source such as the sun, a fire, a torch, and so on. So sources of light produce light, and those rays of light then bounce off of different materials, different surfaces, and those reflected rays of light then enter our eyes, and that's how we detect those rays of light, and that's how we see the world around us. So now that we understand what reflection is, let's move on to the laws of reflection. There are two laws of reflection. One of them is an applied law and the other is for our understanding. The first law of reflection tells us that the incident ray, the normal, and the reflected ray all lie on the same two-dimensional plane. So what this tells us is basically reflection is a two-dimensional concept, and reflection of light can be drawn on paper, right? So there is no concept of depth, there is no thickness involved, it's just a 2D concept, okay? The second law of reflection tells us that the angle of incidence is always going to equal to the angle of reflection. So angle of incidence is equal to angle of reflection. So let's apply these laws of reflection on to ray diagrams. Now, ray diagrams are simply diagrams that show how light travels from one place to another, whether the diagram shows reflection or refraction or diffraction or something else. Well, that's irrelevant. Ray diagrams basically show how rays of light travel. Okay, so using ray diagrams, we can show how light gets reflected off plane mirrors. Okay. Now, in the laws of reflection, we use some key terms, right? Namely, the normal, the incident ray, and the reflected ray. The normal is simply an imaginary line that we draw for our own analysis. It's an imaginary line that's drawn at 90 degrees to the surface where the ray of light hits the surface, right? So, say for example, you've got an incoming ray of light. The normal would be an imaginary line that is drawn at 90 degrees to the surface. And the normal is drawn as a dotted or dashed line, and it's at 90 degrees to the surface, right? The incoming ray of light is known as the incident ray. So this is in fact the incident ray. So you can remember that as incident is incoming. Both of them start with an in. right? So incident and incoming tells you what we're talking about. The angle of incidence is known as, or defined as, the angle between the normal and the incident ray. So this is the angle of incidence. And it's important to note that the angle of incidence is not the angle between the incident ray and the surface, right? So we're not interested in the angle between the surface and the incident ray, but rather we're interested in the angle between the normal and the incident ray. Now, following the laws of reflection, we know that the angle of the incident ray, the normal, and the reflected ray are going to lie on the same two-dimensional plane. So we can draw all of that onto this paper, or in my case the board, and there is no concept of thickness involved. There is no depth such that the light may come out at a different angle, right? So there is no depth involved. That's the first law of reflection. Using the second law of reflection, we can also see or state that the angle of incidence is equal to the angle of reflection. What that means is that the incoming angle, the angle between the incoming ray and the normal is going to remain the same, going to equal to the angle between the normal and the reflected ray. So the reflected ray will come out at an angle which is equal to the angle of incidence. So here's the angle of reflection. Now, these are the two laws of reflection that you need to be aware of. You need to be able to use these laws properly. And you need to be able to draw appropriate ray diagrams for this. So the angle of incidence is equal to the angle of reflection. We've already discussed how reflection is necessary for us to see the world around us, right? So light is produced by a source. Those rays of light then get reflected off of the surfaces around us, and that's how we see the world around us, okay? So let's imagine we place our eye somewhere where the reflected rays of light will then enter our eyes, right? So here's the eye, and here's the incoming ray of light, which is basically the light that was reflected off of that surface. In this case, it happens to be a mirror. Now, when that light enters the eye, our brain basically processes that information to create the images that we see, right? So, because our brain is so fine-tuned to rays of light traveling in straight rays only, it perceives those rays of light, those reflected rays of light, not to be bounced off of different surfaces. So it doesn't perceive those rays of light to be coming from different directions, but rather it perceives those rays of light to be traveling in straight rays. So your brain basically imagines, it perceives those rays of light to be coming from straight ahead instead. So this is what your brain imagines. It perceives this, right? And because this ray of light isn't really there. It's something that your brain has imagined. It's perceived. It's imagined that reflected ray of light to be coming from straight on ahead, rather than being bounced off and changing directions. So because it's something in your brain alone, it's not really there, it's called a virtual ray. Virtual rays are rays of light that cannot be projected onto a screen. They cannot be captured on a film. They cannot be captured on camera. They're not really there. So let's explore these ideas a bit further using a simulator. Over here we've got a diagram, a ray diagram that shows an incident ray, an incoming ray, and how it gets reflected into a reflected ray. We've got the dotted normal, which is an imaginary line that we draw for our analysis. The normal is drawn at 90 degrees to the surface. The angle of incidence is measured from the normal to the incident ray, and the angle of reflection is the angle between the normal and the reflected ray. Let's see how the angle of reflection will vary as we change the angle of incidence. So as we increase the angle of incidence, so as the angle between the normal and the incident ray increases, you know how the angle of reflection also increases to stay the same. So wherever you move that incident ray, it doesn't really matter what angle you select. It doesn't really matter. As long as you have an incident ray, it's going to. So wherever you move or wherever you change that angle of incidence to, the angle of reflection adapts accordingly. It changes accordingly. The angle of reflection will always remain equal to the angle of incidence, right? So the incoming angle between the normal and the incident ray is going to always equal to the reflected angle, the angle between the normal and the reflected ray, the angle of reflection. So let's use our knowledge on laws of reflection and ray diagrams to explore how an image can be formed in a mirror, right? So here's the mirror, and here's the original object with the incident rays drawn, okay? So the incident rays, the incoming rays are drawn in blue, and the incident rays strike the mirror at different points. Now, according to the law of reflection, the angle of incidence is going to be equal to the angle of reflection. So if we draw the dotted lines, if we draw the normals at 90 degrees to the surface of the mirror, you'd see that the angle of incidence will always equal to the angle of reflection. So whatever the angle between the blue line, blue incident ray, and the normal is, that orange dotted line is, right? So whatever that angle is, it's going to always equal to the angle of reflection, which is the angle between the dotted normal and the reflected ray. Okay? So we've basically managed to follow the laws of reflection to create this simple or rather complex ray diagram. Now we can extend those reflected rays further to now form those points, or to find those points where the rays of light will converge to form the image of this object, okay? So if you start extending the lines, remember how we discussed that the eye is placed at those, or in front of those reflected rays, and your brain basically perceives the reflected rays to be coming from dead on, straight on, and not to be bounced off of different places, because your brain is so fine-tuned to rays of light traveling in straight rays. So the brain basically imagines those rays of light coming from straight ahead. Okay, so you've got these rays of light. So you basically extend the reflected rays using dotted virtual rays, and the points where those rays of light will converge are basically coincide with the points from which the rays of light initially were incident from. So the virtual image that is formed basically coincides with the point of intersection of those virtual rays. We can describe the images that are formed as being virtual. So again, virtual means that the rays of light, and hence that image as well, cannot be projected onto a screen. It doesn't really exist. It's just a figment of your imagination, okay? So it can't be captured on film, and it can't be projected onto a screen. It's not really there. So the image that is formed is virtual. It's upright. It's the same way up as the original object. It's laterally inverted, so the left and right hand sides are flipped. It's the same size as the original object, and it's the same distance away from the mirror as the original object was. So those are basically the characteristics of the image that is formed. With that, take care and bye.